Right now, millions of silent exchanges race across the globe. We don't see physical goods moving, but the verifying data is in constant, rapid motion. This is the digital economy. It operates not through physical cash exchanges over a counter, but on a foundation of computing power, software, and vast digital communication networks. Most people use the terms e-commerce and e-business interchangeably. That is a structural mistake. E-commerce describes a very narrow action. It is strictly the transactional layer, the final step of buying and selling a product over the internet. Look at this breakdown. E-business is the holistic superset. It encompasses the total integration of information technology across every single internal and external operation of a firm. Electronic commerce is just one component of that larger machine. To accurately map how the digital economy functions, we have to look past the shopping cart. We must build a digital enterprise from the ground up, starting within its core architecture. Treating a modern company like a simple online storefront ignores the reality of its operations. E-business requires the optimization of the organization's entire internal nervous system. Let's construct this internal infrastructure, beginning where the company's lifeblood is tracked, the finance department. This document outlines the application of IT in financial accounting. Physical ledgers are replaced by software packages that automate invoicing and handle bank reconciliations automatically, stripping out manual data entry errors. By utilizing electronic funds transfer at point of sale, or EFTPS, alongside online banking, a company gains real-time visibility into its cash flow and bypasses the friction of physical payments. Moving to human resources, we see a similar optimization. IT manages the entire employee lifecycle. From tracking initial recruitment to logging daily attendance and evaluating long-term performance, the data is housed within a human resource information system. This system feeds directly into a business-to-employee, or B2E, portal. This provides the workforce with a dedicated interface for reviewing their own metrics, accessing training materials, and communicating with management. With capital and personnel digitized, we turn to the production floor. Before physical goods are manufactured, they must be mapped through an engineering software stack. This text details the production IT stack. It begins with computer-aided design, or CAD. This allows engineers to map out the exact geometry of a product virtually, requiring zero physical overhead for initial prototyping. Once designed, the data moves to computer-aided manufacturing, or CAM. The software translates those digital designs into machine code, taking direct control of the physical production equipment to ensure absolute precision. Finally, we have simulation software. By virtually testing how a product handles stress or environmental factors, the firm predicts durability and eliminates physical waste from the testing phase. Long before a customer clicks a buy button, the architecture of an e-business is already functioning to drive down internal costs and increase operational precision. Once a company's internal operations are optimized, it must decide how to project its presence to the consumer. How does it build its storefront? According to the source material, there are three primary models. The first is the pure brick organization. This is a traditional storefront operating entirely offline, relying strictly on face-to-face interaction between buyer and seller. The exact opposite is the pure click organization. This entity exists exclusively online. There is no physical retail space for a customer to visit. The entire sales process happens virtually. The hybrid approach is the brick and click organization. It maintains a physical retail footprint while seamlessly integrating an online or phone-based ordering system, capturing both traditional foot traffic and digital consumers. Naturally, both the pure click and hybrid models require robust digital payment mechanisms. Debit and credit card processing systems are absolute prerequisites to close these remote transactions. The model a company selects determines its logistical burden. A physical footprint requires real estate and localized inventory, while a pure digital presence demands aggressive investment in servers and shipping networks. When a business builds an online storefront, an e-marketplace, it divides it into two halves. The front end is what the consumer sees, the search bars, product listings, and the shopping cart itself. Behind that is the back end. This invisible machinery activates when an order is placed, managing inventory depletion and triggering the fulfillment cycle. This dual-layered infrastructure enables a dense, multi-directional matrix of transactions across the entire economy. Looking at the classifications of e-business transactions, we see familiar models like business to consumer, but beneath that sits business to business, or B2B. Here, companies use e-procurement to source raw materials and components directly from other manufacturers. These B2B interactions often rely on digital e-hubs or exchanges. These are centralized platforms where multiple suppliers list bulk goods, allowing corporate buyers to source their supply chain from a single interface. The matrix also bypasses corporations entirely. In a consumer-to-consumer model, individuals utilize digital platforms to sell used goods directly to other individuals. The flow can also be inverted. In consumer-to-business, a single individual, perhaps an independent developer, can sell a custom piece of software back to a large corporation. Even the state is integrated. This section outlines business-to-government transactions, where firms supply tech infrastructure or bid on government tenders. Conversely, government-to-consumer services digitize the state's relationship with the public. Instead of waiting in lines at a municipal office, citizens can pay property taxes, renew vehicle licenses, or check national exam results instantly through state-run portals. The digital matrix turns every participant, from the largest tech conglomerate to a single taxpayer, into an active node within a globally connected economy. By aggregating so many nodes onto shared platforms, the digital matrix creates entirely new mechanisms for establishing the price of a good. In a traditional physical auction, a single seller presents an item to a crowd of buyers. The buyers compete against each other, driving the price upward until only one remains. This table highlights the exact opposite mechanic, the reverse auction. Here, a single buyer announces a need for a service. Multiple sellers then compete against each other, driving their bids downward to secure the contract. The lowest bid wins. There is also group purchasing. Individual consumers combine their separate orders into one massive block to hit a volume threshold, securing wholesale discount pricing that they could never achieve alone. Specialized e-marketplaces monitor these pooled orders. Once enough demand is registered, the platform negotiates the final bulk price with the supplier and coordinates the distribution. In a traditional retail setting, a consumer accepts the price on the tag. Digital bidding allows participants to submit offers rapidly and secretively, accelerating the transaction cycle. These mechanics strip pricing power away from the supplier, placing leverage directly into the hands of organized, technologically connected buyers. Every single transaction, bid, and click across this matrix generates a trace. Multiplied by billions of global interactions per day, this creates a massive, continuous volume of raw data flowing into corporate servers. This data fuels database marketing. By capturing every action a user takes on the front end, businesses build deep profiles of individual consumer behavior and preferences. Specialized entities called information brokers exist to collect, package, and sell this data. They provide targeting coordinates that allow other businesses to focus digital advertising with extreme precision. Look at this explanation of data mining. Firms take these massive historical datasets and use advanced algorithms to detect hidden patterns, predicting future consumer behavior. When artificial intelligence models process these predictions, businesses pivot their production. Instead of just manufacturing generic goods for a mass audience, they offer highly customized products tailored to specific, verified demands. The structural advantages of an e-business architecture are substantial. It provides continuous access to a global market, targeted marketing, and the ability to eliminate costly middlemen from the supply chain. However, it requires capital. Establishing this infrastructure demands high initial IT investment, constant vigilance against security breaches, and complex logistical networks to handle physical fulfillment. This integration produces a self-learning system, an organization built to anticipate market moves before the consumer even initiates a search.